I'm Tim. This PCB Sync.
The parameters of Rogers RO4350B and RO4003C look very similar. So how should you choose between them? In this video, we'll compare these two materials from several aspects: dielectric constant, loss, thermal performance, flammability rating, and their impact on actual design. Let's take a look at the datasheet. The process dielectric constant of RO4350B is 3.48 plus or minus 0.05. For RO4003C, it's 3.38 plus or minus 0.05. When used for transmission line design, the design dielectric constant for RO4350B is 3.66, and for RO4003C, it's 3.55. In terms of loss, under conditions at 10 GHz and 23 degrees Celsius, the typical DF value for RO4350B is 0.0037, while for RO4003C, it's 0.0027. So, based on the official typical values, RO4003 has lower dielectric loss. RO4350 can't simply be considered a high-performance upgrade of RO4003C. Let's take a look at a PCB example. This is an open-source distributed phase shifter operating at 5.8 GHz. J2 is the input port, J1 is the RF output, and J3 is used for bias control. TR1 to TR4 in the middle are transmission line structures. Their width and length directly affect impedance, electrical length, and phase. Because RO4003 and RO4350B have different design decay values, the same board layout can't be directly swapped between the two materials. If you change RO4003 to RO4350B or vice versa, you need to recheck the dielectric thickness, trace width, transmission line length, and matching results. Choosing high-frequency materials isn't just about changing the material name, it's about reconfirming the entire stack-up and electrical dimensions. Now let's go back to the datasheet. Let's look at the thermal performance. The z-axis coefficient of thermal expansion for RO4350B is 32 parts per million per degree Celsius, while for RO4003C, it's 46 parts per million per degree Celsius. Both materials have a TG greater than 280 degrees Celsius. The TD of RO4350B is 390 degrees Celsius, and for RO4003C, it's 425 degrees Celsius. In terms of thermal conductivity, RO4350B is 0.69 watts per meter Kelvin, and RO4003C is 0.71 watts per meter Kelvin. The two are very close. The real obvious difference is the flammability rating. Standard RO4350B meets UL94V0, while standard RO4003C does not have this rating. If the product specification clearly requires V0 certification, RO4350B is usually the more straightforward choice. Now, let's take a look at the differences in their processing. In terms of applications, RO4350B is often used in base station power amplifiers, communication equipment, and other RF/microwave products that require a flammability rating, while RO4003C is more suitable for RF designs that do not require V0 certification, but still focus on low dielectric loss and cost control. When it comes to the processing stage, both of these specific materials belong to the RO4000 series and are capable of utilizing production processes similar to FR4. They typically do not require the special treatments common to PTFE materials before metallization and are compatible with tin copper plating and direct metallization processes. So the main difference between the two is not that one is easy to process and the other is difficult, but rather their electrical parameters and flammability certification levels. Besides performance, you also need to consider cost and supply, but the datasheet won't give you a fixed price, and you can't simply assume that materials with a lower DF are always more expensive. The actual cost will be affected by material thickness, type of copper foil, order quantities, stack up, inventory, and lead time. Therefore, you can't judge cost and supply just by the material model. You should provide the board thickness, number of layers, copper thickness, quantity, and lead time requirements to the PCB manufacturer for a quote. The same material can have different prices and lead times depending on the specifications and purchase timing. So to sum up, if the project specifically requires V0 flame retardant certification, you can prioritize evaluating RO4350B. If V0 is not required and you are more concerned about lower dielectric loss, you can prioritize evaluating RO43C. However, the final choice should also take into account working frequency, board thickness, impedance, copper foil insertion loss, thermal reliability, inventory, and cost. Don't think of RO4350B as a complete upgrade over RO4003C, and don't choose a material based solely on a single DF value. Whether you ultimately choose RO4350B or RO4003C, PCBC can assist you with material recommendations, stack-up evaluation, impedance calculation, and DFM review. Scan the QR code in the image and upload your Gerber files to start your inquiry. If you found this content helpful, please like and subscribe.